Welcome everybody. In this video I'm going to perform 5 example calculations regarding our density formula. One of the first things I want to do is I want to write the density formula up here on the top for you. Now what I would encourage you to do is to attempt these 5 examples on your own and then resume the video to check your answers and verify that your calculations are correct. And if at any point you get stuck, then you can obviously refer to the video to help you get unstuck. So the density calculation is density, which is a capital D, is equal to the mass, which is a lowercase m, divided by volume, which is a capital M. So density equals mass divided by volume. So in our first example, it says a block of aluminum occupies a volume of 150 milliliters and weighs 40.5 grams. What is its density? Okay, so I know by looking at this that I need to solve for density. So I'm going to write here on the left, density equals question mark, because I don't know. That's what I need to solve for. It says the aluminum occupies a volume of 15.0 milliliters. I know that this is measuring the volume of my aluminum. So I'm going to write over here to the left that the volume is 15 milliliters. And then it tells me it weighs 40.5 grams. Grams measures mass. If it says that it weighs a certain amount of grams, this is referring to mass. So the mass is 40.5. So I'm going to write it over here to the left. That M, mass, is 40.5 grams. Let me fix that equal sign. There we go. Okay, so now using my equation, density equals mass divided by volume, I'm going to plug in the values that I know. So density is still unknown. I'm going to leave it as D. M is 40.5, so on the top here I'm going to write 40.5 divided by V is 15. So I've got it set up properly. I've got 40.5 in the numerator, 15 in the denominator, and now when I calculate, you're going to type in the top number first. So 40.5 goes into the calculator first, divided by 15. And when you calculate that, you should get 2.7. And then my units, I'm measuring grams over milliliters, so it's going to be grams per milliliter. Okay, let's look at another example. Example number 3 here. Again, I encourage you to pause the video, try to solve this on your own, and then resume the video when you'd like to check your answer. So here it says, what is the weight of the ethyl alcohol that exactly fills a 200 milliliter container? The density of ethyl alcohol is 0.789 grams per milliliter. So it says, what is the weight? So anytime you're measuring the weight of something, you're stepping on a scale. In other words, you're placing something on the scale, you're measuring the mass of that object. So here, when it says, what is the weight? I'm solving for mass. So mass is my unknown. It says it fills a 200 milliliter container. So it's telling you that this is the volume of that ethyl alcohol. And then it gives you the density of the alcohol is 0.789 grams per milliliter. So let me write my volume, which we said was 200 milliliters. And the density was 0.789 grams per milliliter. Okay, now I'll set up my equation. Density equals mass divided by volume. And I'm going to plug in what I know. So this time I do know density, and my density is 0.789 equals, now the mass is unknown, but the volume is 200. Okay, so now it's a little bit different than up above. I'm solving for mass instead of density. So here there might be an additional step. So I want to get mass by itself. If it's on the right side of the equal sign, I'm going to go ahead and leave it there. And what I'm going to do, because I've got a fraction on the right, I'm going to turn the left side into a fraction so that I can cross multiply. So in order to make the left side of the equation a fraction, all I have to do is put it over 1. And when I do that, now I can cross multiply. So now I can cross 0.789. Actually, let me do it this way. I'll cross 200 times 0.789 and 1 times m. So we know that 1 times m is m. And then on the right side, I've got 0.78. Actually, let me do this. I'm sorry. I'm going to keep it on the same side that it was. So 1 times m is 1m, or just m. And then on the left side, I've got 0.789 times 200. Okay? So calculate that. 0.789 times 200. That gives me 157.8. And that is in grams equals my mass. Now, if you did not calculate 157.8, I encourage you to try the calculation again so that you can perform it correctly. All right, let's move on to the next calculation, which is on the next page here. Again, I encourage you to write these out or calculate them on your own by pausing and playing the video. Number 7 says, find the mass of 250 milliliters of benzene. The density of benzene is 0.8765. So again, we are going to find the mass. So my mass is unknown. I'll write that down here. Mass is unknown. It says 250 milliliters of benzene. Milliliters is a unit that measures volume. The density of benzene is 0.8765 grams per milliliter. So it's telling you this is density. So on the left, your volume is 250. And your density is 0.8765. Now remember not to round your answers until the final solution. The more you round it now, the more off your final answer will be. So leave your density as 0.8765. All right, so your equation is density equals mass divided by volume. So now I'll plug in what I know. For density, we said the density of benzene was 0.8765. So 0.8765 equals the mass, which is what we're trying to solve for, divided by the volume, which is 250 milliliters. Okay, so like the previous problem, I've got mass in the numerator on the right side, and it's part of a fraction, so I want a fraction on the left and the right. So the easiest way to do this is to put this over 1. So now that I put that over 1, I can essentially cross multiply. So multiply 0.8765 times 2500 and 1 times m. So 1 times m is m, and then on the left I got 0.8765 times 250. And when I multiply 0.8765 times 250, I get an answer of 219. I'll write that over here. 219.125. And now I can round my final answer. I'll say 13. I'll round up 0.125 to 13. Okay. Number 9 in this worksheet says 28.5 grams of iron shot is added to a graduated cylinder containing 45.5 milliliters of water. The water level rises to 49.10 milliliters. What is this? From this information, calculate the density of iron. Okay, so this one's a little tricky, just because it involves an extra step, but that's okay. It says 28.5 grams of iron shot. So those are just small pieces of metal of iron. This is mass. Okay, so you know the mass. We'll write it over here, 28.5 0.5 grams. It's added to a graduated cylinder containing 45.5 milliliters of water. And then it says when you put the iron into the graduated cylinder, the water level rises to 49.10. So this is measuring volume, this is measuring volume. So if you are trying to measure the density of something that is irregularly shaped, something you cannot just measure the volume using a ruler, measuring length times width times height, then typically water displacement helps you find that volume. So in this case, the metal shot, the pieces are too small to measure with your ruler. So this person is putting them into a graduated cylinder that is already filled with water. And as you probably know, if you step into your bathtub that is full of water, then your body is displacing that water, and if it's too full, then that water pours over the side of the bathtub. Same thing is here. If I pour the metal shot into the cylinder containing water, that water level is going to rise, and that's what it's showing you here. So 45.5 milliliters is the original volume or the starting volume. We call that VI for initial volume. So that means when it rises to 49.10, that's the final volume, or VF. So to find the total volume, we're going to take VF and subtract VI. So if your final volume is 49.10 and your starting volume was 45.5, we can subtract the two. So 49.10 minus 45.50 gives me 3.6. So what that says is the iron shot, the pieces of iron, have a volume of 3.6 milliliters. And I want to calculate the density. So now I'm going to use my density formula just like I always have. Mass divided by volume, where I'm solving for density. Mass was given to me as 28.5. And the volume we determined to be 3.6. So when I type this into the calculator, and remember the top number always goes first, 28.5 divided by 3.6 gives me a volume of 7.91666667. We're going to round. We don't need all those sixes. We're going to say 7.916 rounds to 7.92 grams per milliliter. Okay, let's try another one. It says, what volume of silver metal will weigh exactly 2,500 grams? The density of silver is 10.5 grams per cubic centimeter. Okay, so I want to solve for volume. So volume is unknown. It says it weighs exactly 2,500 grams. So anytime it says something about weight, that's referring to mass, which is M. So 2,500 is M. Okay, and I'll add a 2,500.0 if you like. The density of silver is 10.5 grams per cubic centimeter. So density is 10.5 grams per cubic centimeter. So cubic centimeters is another unit to measure volume. So same equation, density equals mass divided by volume, where my density is given to me now, it's 10.5. The mass is given to me now, it's 2,500.0 if you want to add it, and volume is unknown. So just like before, we are going to cross multiply. If I've got a fraction on the right, I want to make the fraction on the left so that I can. So all I'm going to do is put this over 1. And so what I end up getting is 10.5 times V and 1 times 2,500. So I'm going to go ahead and keep the V on the right side. So I get 10.5 times V. And on the left, I get 1 times 2,500, which is just 2,500. So I'm not done yet. I need to get V by itself. I'm going to leave it on the right side. Notice how it is being multiplied by 10.5. If I need to move this to the other side, I have to perform the opposite operation. So if these are being multiplied, the opposite is to divide. So I'm going to divide both sides by 10.5. Divide this side by 10.5, and the 10.5s cancel out. So that leaves me with V all by itself. And now I can perform the calculation. 2,500 goes in first, divided by 10.5 goes into the calculator second, and that gives me a value of 238.0952381. So I'm going to round, say 238.095. We'll round that up to 0.10. And this is measuring in cubic centimeters. There's my volume. So I want to look at one more. I apologize. One more. I realized that there's one more example that I would like to do, and that is measuring the volume of a regular shaped solid, so a rectangular prism or a cylinder or a sphere, things that we know the equation for the volume of that object. So we're looking at number 8. Let's look at number 8. Number 8 says a block of lead has dimensions of 4.5 by 5.20 centimeters by 6 centimeters. The block weighs 1,587 grams. From this information, calculate the density of lead. Okay, so it's telling me that I need to calculate the density of lead. Okay, so I know that D is unknown. It says it weighs 1,587 grams. This is mass. Okay, and then it says it's got dimensions of 4.5, 5.2, and 6. So essentially you have a block. And I'll try my best to draw it. Okay, so it's telling you that one side is 4.5. The other side is 5.20, and the other side is 6.0, all in centimeters. So you're not given volume. What it's telling you are the dimensions of this object so that you may calculate volume on your own. So remember, volume of a regular shaped solid is length times width times height. So the volume is, and it doesn't matter which is which, we'll say 4.5 times 5.20 times 6.00. And when I multiply those together, 4.5 times 5.2 times 6, I get 140.4. And this is cubic centimeters because I've got centimeters times centimeters times centimeters, which is centimeters to the third power. So now I can write my volume to the left, which is 140.4. And now I can calculate density. So density equals, let me do this in a different color so you can see it better. Density equals mass divided by volume. So density is unknown, that's what you have to calculate. The mass is 1,587 grams, and the volume we just determined to be 140.4. So 1,587 goes in first, divided by 140.4. That gives me a density of 11.3034188. Now I'm going to round simply to 11.303 would round to 30. And this is grams per milliliter. All right, so hopefully these calculations are good examples for you. As you're working through your classwork, you are certainly welcome to refer back to these calculations to see how the functions are performed.